Good morning. Today going to be doing the question on complex numbers. Don't forget to share, like. We are given the question there. It is given that fx is equal to x cubed plus x squared minus x plus 15. Given that 1 plus 2i is a root of fx is equal to 0. State the other complex root of fx is equal to 0. So it's part A 1. So when you know one complex root of an equation, the other one will be the conjugate of the given complex. So it means the other one is 1 minus 2i. That's the other root. Then we go to the second part. It's saying hence or otherwise solve the equation. So we are going to use the hence. Here we are going to use the hence. If they say hence, it means we are going to relate with what we are given below. So with what we are given above. So basing on what we are given above, we are having the roots x is equal to 1 minus 2i and x is equal to 1 plus 2i as the roots of our equation. So using these roots, we can get the factors of the equation. So here are the factors of our fx, factors of fx that we can extract from there. We just transpose those roots. So it's going to be x minus 1 plus 2i as the other root and x minus 1 minus 2i as the other root. So to simplify, we can simplify these linear roots by multiplying them so that we get the quadratic root. So it means we are going to have x squared minus x multiplied by 2i, then minus x plus 1 plus 2i plus x 2i minus 2i minus 4i squared. So simplifying this, we are going to get x squared minus x is going to give us minus 2x, then minus x2i plus x2i will go, then we are going to have plus 2i minus 2i, then minus 4i squared, it gives us minus 1. Minus 1 times minus 4, it gives us plus 4. So our last term is going to be plus 1 plus 4, which is going to give us plus 5 here. So we now have a quadratic factor. We have a quadratic factor. We will now want to get the linear factor. We can use long division now. So it's going to be here we are having x squared minus 2x plus 5. Then the other side we are going to be having the cubic function, which is x cubed plus x squared minus x plus 15. X squared into x cubed is x. X times x squared is x cubed. X times minus 2x is minus 2x squared. X times positive 5 is going to be plus 5x. Then we subtract here x cubed minus x cubed is 0. X squared minus minus, which becomes plus 2x. So it's going to be 3x squared. Then we have minus x minus plus, which becomes minus x minus 5x. It gives us minus 6x. Then we bring down the 15. So x squared into that, 3x squared is going to be plus 3. 3 here is going to be 3 x squared, 3x squared here minus 6x plus 15 here, which gives us 0. So it therefore means that our fx is equal to x squared minus 2x plus 5, then x plus 3. Equating this to 0, it will mean our 0 is equal to x squared minus 2x plus 5, then x plus 3. Equating this to 0, it will be 0 either x squared minus 2x plus 5 is equal to 0, or x plus 3 is equal to 0. So it will therefore mean that x, because the roots of this one, you can use the quadratic formula, but we already have the solutions for this one. So x equal to 1 plus 2i, or x is equal to 1 minus 2i, or x is equal to minus 3. So these become our solution. Now we are going to proceed. We are now on part B. We are now on part B 1, and the DeMoivre's theorem or identity. So the DeMoivre's theorem states that sin theta cos theta plus I sin theta to the power n is equal to cos theta plus I sin n theta. Then in this case we are talking of 5 theta, so it means we are going to raise to the power 5. So it's going to mean that cos theta plus I sin theta raised to 5 will be equal to cos 5 theta plus I sin theta, like that. So the I sin is 5 theta. Then from there we again take cos theta plus I sin theta, we raise it to the power 5. Here we are going to expand using the Pascal triangle. Our coefficients, as we can see, 1, 2, 1 to the power 3 to the power 4 to the power 5 is going to be 1, 5, 10, 10, 5, 1. So using that, we are now going to have cos, then plus 5, the cos to the power 4, then we have I sin theta plus 10, the cos to the power 3, then I sin theta, it's now squared, then we are going to have plus another 10, then we have cos squared theta, then I sin theta cubed plus 5, we are having cos theta then I sine theta to the power 4, then plus I sine theta to the power 5. Then we know that if complex numbers are equal, it therefore means they are real parts. They are identical, and they are imaginary parts. They will be identical. So in this case, we can now conclude that therefore cos 5 theta, which is the real part, will be identical to the real part of this expansion, and the real part is the one which is not having I. So we are having cos, then we take the one where I is being squared, so it's going plus 10 cos cubed theta, but here I squared, it's minus 1, so it's gonna be minus sine squared theta. We take where I is having an even power, then we are having plus 5 cos theta. I to the power 4 is positive 1 times sine that one, so it's going to be sine power 4 theta. Conclusively, it therefore means that our cos 5 theta is identical to cos, there is 5 theta. Here it's gonna be minus because of this negative 10 cos cubed theta sine squared theta plus 5 cos theta sine to the power 4 theta. That is using the DeMoivre's theorem, but you have to take note the question was saying or otherwise. So if we are to use the otherwise part, it simply means we are going to have our cos 5 theta, which is equal to cos theta plus 4 theta. So using that, we are going to use the identity. First identity, cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. So applying that, it will mean that this one is going to be cos theta cos 4 theta cos theta cos 4 theta plus, it's minus not plus, minus sine theta sine 4 theta. So it's cos theta, this one is double angle, so it becomes cos 2 times 2 theta minus sine theta sine 2 times 2 theta. So here we are going to have cos theta. Then in this case, we are going to use the identity, which is having cos 2 alpha is equal to, there are different identities, but because the question is combining cos and sine, there we are going to use the identity which says cos squared alpha minus sine squared alpha. So where there is that, we substitute, it's going to be here, so it becomes cos squared 2 alpha cos squared 2 theta minus sine squared 2 theta minus sine theta. Where there is sine theta, there we are going to change it. where we are having sine 2 times an angle, which is the formula double angle. So it means we are going to use the formula sine 2 alpha is equal to 2 sine alpha cos alpha. So it therefore means where there is that, we are going to put 2 sine 2 theta cos 2 theta. Then we expand. If we are to remove brackets, okay, we can expand here so that it becomes cos. Then let's put a bigger bracket, a square bracket. Where there is cos 2 alpha, we are going to put it as cos squared. So it means we are going to have cos squared theta. We are going to use this identity minus sine squared theta, but it's being squared, minus, where there is this identity sine 2 alpha, we are going to put 2 sine theta cos theta. It's being squared, we square that, we close. Then we are going to have minus, we have 2, let's take the 2 outside, so it's going to be minus 2 there, sine theta. Then we put a square bracket. Where there is 2 there, where there is sine 2 theta, we are going to put 2 sine theta cos theta. Then where there is cos 2 theta, we are going to put cos squared theta minus sine squared theta. We leave, we expand. So here we are having cos theta outside. Then we expand. So it simply means here, this one becomes cos the power 4 theta minus 2 cos squared theta sine squared theta plus sine to the power 4 theta. It's going to subtract this one. So it's going to subtract 4 sine squared theta. It's 4. If we are to start with cos, it's gonna be cos squared theta sine squared theta. Then we are having minus 2 sine theta. Simplifying this bracket, it's gonna be 2 cos and cos. It's gonna be cos cubed theta sine theta. Yeah. Then this again is gonna be minus. So now are we going to make it be minus here 2, then we only have cos theta then sine cubed theta. Then from there we are going to simplify here. This and this is going to be cos, then it's to the power 5 theta minus 2 is going to be cos cubed theta sine squared theta. Here it's going to be plus cos theta sine to the power 4 theta. Then here it's gonna be minus 4 cos is gonna be cubed theta sine squared theta. Then we are having minus 4 the cos cubed theta sine squared theta, minus, and a minus is going to be plus 4 cos theta sine cubed theta. Then it's equal to cos to the power 5 theta. Then we go to the ones with cubed. We see we are having minus 2 cos cubed minus 4 cos cubed sine squared minus 4 cos cubed sine squared. When we combine them, we are going to get minus 10 cos cubed sine squared theta. Then lastly, when we combine the one with cosine to the power 4, that one and that one, is going to be plus 5 cos theta sine to the power 4 theta. That becomes the answer if you were to use the alternative method. However, it's very long. If you check, our answers are the same, this one and this one. Then we go to the next question. What are they saying on the next question? On the next question, it's now saying, let's go up. It's now saying, hence or otherwise express cos 5 theta as powers of cos x. So it means here we are going to apply the hence. I'm going to limit this one to the hence. The or otherwise, it means on this identity where we substituted the identity which are accommodating cos and sine, we would use any identity, but it was going to be very long. Now on this one, we are having that is B part 2. That is B part 2. So we are having our cos 5 theta being equal to cos here to the power 5 minus 10. We are having cos cubed sine squared plus 5 cos theta. Then we are having sine to the power 4 theta. So in case of this one, we were supposed to apply the Pythagorean identity. Which says sine squared theta plus cos squared theta is equal to 1. So to eliminate the sine squared, it simply means you transpose that. So it means sine squared theta is equal to 1 minus cos squared theta. So wherever the sine squared theta, we are now going to substitute 1 minus cos squared theta. So it therefore means it was going to reduce to, so it becomes cos 5 theta will be equal to cos here minus 10. We have cos cubed theta Then where we have sine squared, we substitute 1 minus cos squared theta, then minus 5 cos theta. Where we have sine, it means here where we are having sine to the power 4, we take it as sine squared theta, then we square that. So if we do that, that simply means we are going to have 1 minus cos squared theta squared. Simplifying this, it reduces to cos power 5 theta. Then this one and this one is going to be minus 10 cos cubed theta, minus and the minus is going to be plus 10, then cubed and squared is gonna be cos to the power 5 theta. Then we have minus 5 cos theta. This expansion is gonna be 1 minus 2 cos squared theta. Let's try to minus 2 cos squared theta plus cos to the power 5. Sorry, to the power 4 theta. So expanding that, it's going to give us cos to the power 5 theta minus 10 cos cubed theta plus 10 is cos to the power 5 theta. Then here minus 5 cos theta, this one and this one, plus 10 cos cubed theta, that one and that one, it becomes minus 16. Sorry, minus 5, not 16. So it's minus 5 here. If this comes here, then cos to the power 5 theta. Then when you expand the ones with to the power 5, it's this one, and this one. Kindly take note, I made an error here. It's plus, not minus. Here it's plus, not minus. From our proof, it's plus. There. We have to take note for those errors, even when it comes to exam. Here it's plus, so it means it was supposed to be plus. Then here it was supposed to be minus. There. Then the last one is plus. So if we say 110, we are going to get 16 cos here. Then we check the ones with cubed. You see we are having this one, this one. So it's going to be minus 20 cos cubed theta. Then we take the one with, which is going to be plus 5 cos theta to get that. Then we go to the last question. Let's go to last part C. They are saying on an Argand diagram, There it is. On an Argand diagram, sketch and shade the region whose points represent the complex number z which satisfy the inequality. So we are having the inequality which is given by, that is part C. They said modulus of z minus 3i is less than 2. So to get the, it's an inequality, so to get the critical values of our inequality, this one is z. So to get the critical values of our inequality, critical values of our inequality, we are going to assume that z is equal to x plus iy. We are just going to write our complex number in the form of, we write our complex number there. We write our complex number in Cartesian form. So it means we are saying modulus of x plus iy minus 3i is equal to 2. We changed it because we just want to check the critical values. So we would realize that it's more, we write this, the real part is x, our imaginary part is x, it's going to be y minus 3. This is our complex number, is equal to 2. So if we are to check modulus of this, it's going to be x squared plus y minus 3 squared equal to 2. And from here we can see this is the equation of a circle. This is the equation of a circle. So this shows our critical values is the equation of a circle, which is having center 0, 3, and r equal to 2. Taken from the general equation of a circle, it says what? X minus a squared plus y minus b squared equal to r squared, where the center of the circle is a, b, and the radius of the circle is r. So to draw this diagram, it therefore means we are going to have our Argand diagram is going to be like this. We are going to have our vertical axis. Let me draw it in blue. We are going to have our vertical axis there. That is our imaginary part. Then our x-axis. Then our center is going to be here, where it's 0, 3, and we see we are going to have a circle there. Okay, let's draw. We are going to have a circle if you check, because our radius is 2, so it will mean here it's going to be 0. We were at 3 here, so it's 0, 5, because radius is 2, and here it's 0, 1 there. But that's the circle, but the inequality is saying it's less than 2, so it means we will have to shade inside the circle. We have to shade inside the circle. That's how our Argand diagram is going to be in this case. We shade inside the circle. Thank you very much. Don't forget to share, like, subscribe, and comment. Don't hesitate to ask questions where you don't understand.